Hello, welcome. This is Professor Roldan with Introduction to Probability and Statistics. This is section 3.4. Although we went over most of this in class, there is page 3 that we still need to discuss so that you have a better understanding and be able to do some of the work in your assignment for 3.4. So this is a video to cover things that I either leave out or just run out of time or I'm not able to make it to class or for whatever reason. Okay, I usually have 4 of my 5 courses at Southeastern are flipped, which means the instruction or the lectures are all on videos and are watched before class, and we do problems and activities in class. So this is sort of like that, but this is the same method that I use for my other classes. So let's begin. So first of all, the beginning of 3.4 is relative standing in Boxplots. So we didn't get time to do Boxplots. So as you can see here, last week we talked about pages 1 and 2, and then this video is going to do page 3, which is mostly Boxplots. Okay. All right. So just let me review this. These are the notes already filled out. So we have the measures of location of data values relative to other values can be used for comparison, and we talked about how this can be z-scores, percentiles, and we didn't do quartiles, okay, which we're going to do today. So quartiles and Boxplots, which these two are related. Okay, these kind of go together. So then we have basic concepts. So we have the formulas for the z-score. So what this does is standardizes the value. Okay, so if you have 2 different means, you can compare 2 different means and their variation based on this formula here. Okay, you're gonna round the z-score to 2 decimal places. Okay, so let's say your mean is right here in the middle. Okay, and if you have a z-score for a data point, if you have a z-score, let's say a 1, then that's ordinary. Okay, if your data value is a 1.9, it's still ordinary, or even a 2. But if it's 2.1 or 2.9 or 3.1 or anything above 2 is going to be unusual. Okay, it's too far from the mean. Okay, so 95% of the data should be within 2 standard deviations plus or minus from the mean. Okay, so it could be two standard deviations above the mean or 2 standard deviations below the mean. And again, anything less than -2 is going to be unusual as well. Okay, so this z-score has no units of measure. It just wants to know standard deviations. Okay, and of course, anything on the negative side means it's below the mean, and anything on the positive side is going to be above the mean. Okay, so here's a quick example. We did this in class, or at least we did an example of this in class where all of us took our beats per minute for our heartbeats per minute. Okay, and so in this particular example, the sample mean, okay, so the average of all the data points for beats per minute is 67.3. This 48 represents I believe it's the professors, or not the professor, but the author of the book okay, measured his own. And so we want to know, is this, I mean, obviously it's not the average, and is below, but how far is it between the mean? So 48 and 67.3. So you're going to find the difference, okay? But then you're going to take that difference and you're going to standardize it by dividing by the standard deviation. So in this case, one standard deviation represents 10.3. So 10.3 above this, 10.3 below this is one standard deviation. That would be like this area right here. And then, so if you divide it, okay, the 48 beats per minute, this is the location of that. Okay, so if we go back, negative 1.87 is right there. So that 48 beats per minute is, although it looks like it's very far away from the average, it's actually an ordinary value. Okay. So we talked about how it is within the ordinary range. Okay. So let's go ahead and go to page 2. Page 2 talked about percentiles, and talked about how there's 99 percentiles, percentile 1 through 99. Okay, and the way that you actually calculate the percentile value of a data point is going to be you're going to count the values that are less than the data point and divide that by the total. Okay, that's what the N stands for. And then this just converts it to percentage. Okay, so it's the number of values smaller than X divided by the total number of values. That gives you its percentile. So for example, you have 40 data points here. You have 20, and we're going to examine data point 23 chips. So 23 is the 11th data point, or the first 23. So if you count all the data points below, there are 10 data points. Okay, so since 23 is 11th, there are 10 values less than 23. So those 10 data points, that's the number that's below the mean, or below the data point that we're investigating. Okay, so we want to know the percentile of 23 chips, chocolate chips. So this times 100, so that's a quarter. 0.25 times 100 is 25%. So in other words, the percentile of the data point 23 is 25. Okay. So this is the 25th percentile. Okay. And if we said 50th percentile, then we would be looking at the median or the middle. So now, what if you want to go in reverse? In other words, you know the location. You know the percentile, but you want to find the location. Okay, so for example, if I have, I know it's 25%. I want to know if it goes to, I want to know what data point is 23. What data point is 25%? So this is the way to find that. So you take your percentile, divide it by 100, multiply it by the total. Okay, here's the formula. So in this example, we want to know, okay, what's the 18th percentile of the data set we just looked at? All right, so the location at the 18th percentile is 18 divided by 100, multiplied by, there's 40 data points in our example over here. So you do the math with your calculator and you get 7.2. Now because this is a decimal, we round it up. Not round it off, but round it up. Always up. So 7.2 is going to round to the next whole number, which is 8. So that means that this is the 8th location in the data set. Okay? That's what this means. It's the 8th location. So we go find that 8th location. 1, 2, 3, 4, 5, 6, 7, 8. There it is. So here's the 8th location. This is the 18th percentile. So we found that 8 is the location. We go find the 8th location, and it happens to be 22 in this case. Okay. So what we just did there was we followed this chart. Okay. This was already done for you. It was already sorted from least to greatest. We did this part. We got 7.2. Is it a whole number? No. And then we rounded it off, okay? And then we found the 22 from here. Now in the next example, we're not going to get a whole number. Oh, we are going to get a whole number. So then we have to follow this advice, which is, so if we get a whole number, we're not going to round it up. It's already whole. So we have to look at the next value in the data set, and then we're going to find the average of the location we just found and the next value. Okay, and dividing it by 2 is like finding the average, or the middle or the median. So let's do an example here for if we get 25. So we already know the answer to this, right? But or at least pretty close to it. So find the 25th percentile. 25th percentile then is, okay. So remember the location. Is going to be 25. I mean, sorry, 25th percentile is going to be there times 40, and that's going to give you that's going to give you 10, which means it's the 10th location. Okay. But we have to follow this here, which says that the value, the 25th percentile value, so we just found the location, but we're supposed to look at the midway between the 10th location and the 11th location. So from our chart, we can see that the 10th location is 22, and the 11th location is 23. So 22, 23, and it says add those two and then divide by 2, which is basically find the midpoint between those two, and we know that that's going to be right here, 22. Since they're consecutive numbers, that's going to be 22.5. Okay. So the 25th percentile is 22.5. Here's the work for that, if you want to see it. So So it's 45 divided by 2, which is 22.5. Okay. So that kind of wraps up page 2. Now let's go to page 3, which I have provided on MyFire and in my email. You can download it as a PDF. Okay, so this is page 3. This is something you have to access yourself on MyFire or in the email. And so the next thing we're going to talk about is quartiles. So quartiles, just like the name implies, it's a quarter, okay, or fourths. So we divide the set of data into 4 groups, and that creates quarters or sections of 25% of the values in each of the groups. Okay, so quarter 1, or Q1, sorry, is called the first quartile. Okay, and the first quartile is basically the 25th percentile, which that is basically saying you're looking at the bottom 25%. Okay, he represents that location. 25th percentile represents the bottom 25% of the data. And then we go to the second quartile, which is another quarter, which is B50, or the 50th percentile, and this number represents the bottom 50%. And the third quartile. Oh, by the way, this is also the mean. The median. So we already know that the 50th percentile, or halfway in the data, is actually the median. And then the third quarter, or third quartile, is another quarter, so it's 75, and that represents the bottom 75%. Okay. So I'll show you that. You can see the diagram coming up, or you can see that a little bit more clear. Before we get into that, there's some other statistics that you may see the vocabulary throughout the book. So not something you have to memorize here, but the interquartile range is just the range between quartiles. So let's say Q3 to Q1. Okay. What's the range between the third quartile and the first quartile? Semi-interquartile range would be basically the midway between that interquartile range. So we'd have to divide by 2. The mid quartile would be Q3 plus Q2 divided by 2, and then the 10th through 90th percentile range would be just the difference between those 2 percentiles. Okay, so just some simple formulas to keep in mind if you have to deal with this in other areas, or if you just need a vocab. But this brings us to our 5-number summary. Okay, this 5-number summary you can use for any data set. So 5-number summary is going to be the minimum and the maximum, which you already know, and then the first, second, and third quartiles that was just introduced. Okay, and usually the minimum The minimum and the maximum are the easiest to find. It's just the lowest and the highest. And then the other one that's pretty easy would be the median, which is the middle. Okay, and then the first quartile is basically the middle of the first half, and the third quartile is the middle or the median of the second half. Okay, so this would be median of let me put, sorry, and this is the median of the second half. Okay, so let's take a look at the picture over here. So there is your minimum, your maximum, and then your middle right here. Okay, and in the middle between those two would be here, and the middle between the second half would be here. So there's the median of first half, and the median of second half. Okay. So a box plot is basically that same chart we just saw, except if I put a box between, or a rectangle, if I draw a rectangle from Q1 to Q3, then I have a box plot. Okay. So a box plot is the same as box and whisker. Diagram that you probably have done in middle school or high school, depending on where you received that information, but we're just going to call it a box plot. And you can see here from the box and whisker or the box plot, we can see the left whisker or the minimum. We can see the right whisker or the max. We can see the middle. Oops. Let me put that there. You can see the median right there, which is Q2. And then we can see Q1 and we can see Q3. Okay. So we can see all 5 of those numbers from the 5-number summary, and since this is pretty balanced and symmetrical, this would be a normal distribution. And as you can see, the second one is pretty skewed. It's not symmetrical, so it's not normal. And because this has a long tail over here, we're going to call, this is a right tail. This tail is on the right. Okay, so let's go ahead and look at an example from the textbook, number 31 on page 126. Okay. Because you're going to have to do this in your homework, and I just wanted to show you the manual way, but basically you can always just use technology to check your answers. Okay, but you do need to know how to break the numbers down by hand. Okay, without a calculator. Okay, so if you take a look at page 126, number 31, these are the data values. And this is like minutes to get ready or something. Standing in front of the mirror, getting all that prepared for school or whatever. So thank God this is already order from least to greatest. And if you count these, the first thing we notice, and this is always the first thing you want to do, how many data points are there? Okay, there's 18. All right, so we want to go ahead and do, oh, by the way, this is supposed to say by hand without calculator. That's what I meant to write down there, so sorry about that. But anyways, we want to do our 5-number summary. And that means we're going to find the minimum. Q1. Q1, Q2, Q3, and the max. Okay, those are our 5 numbers. So the easiest to start with would be the minimum. Oh, it's the first number. The maximum, the last number. Okay. And then since we have 18 data points or data values, then we know that the middle is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So right there splits it 9 on the left, 9 on the right. So what's the median between 18, or the average between the 18 and 18? Well, it's the same number, so you don't really have to calculate that one. It's just 18. Okay, the middle between 18 and 18 is 18. But then we can find the middle of the left side, or the first half, which is, since there's 9 data points on the left, you're gonna get 4 and 4, and right in the middle is 14. Okay, so you have 4 data points on the left, 4 data points on the right. The middle means it's 14. Okay, that's quarter 1. Quarter 2 is 18. The third quartile, or Q3, is going to be the middle, or the 5th location on the right side. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4. So that means that 32 must be, that's the median of the right side of 30. So now we have all 5 numbers. So when you do your box plot, so you just want to draw the minimum, max. Okay, those are the endpoints, or the whiskers there. Now the middle, you can just write it in the middle. It's just a sketch. But the middle, or the median, is 18. Okay, so if just, what's normally the middle between 4 and 63 is going to be about 30. So I'm just going to put 18 on the left side over here. It's kind of skewed to the right. So, but it doesn't have to be perfect, okay? So that is the median, or Q2. So, and then Q1 is 14. That's about right here. And then Q3 is 32, which is probably around right there. Okay, so all you gotta do is just draw a box. From Q1 to Q3. And voila. Okay. Now let's go ahead and use technology to check our answers here. Alright, so if you have a graphing calculator, you can type these 18 values into a list and follow the directions from the textbook, or you can just look up how to put this in a TI-83 or 4 or whatever calculator you have from from the help or the guide or the instruction manual that you can find online or whatnot. So best bet is to look in the book. You can also just Google it. You can also Google a YouTube video to do that. But I'm going to be using StatCrunch because this is already included in your MyLabs Plus account. And so this is in MyLabs Plus. It's an option on the left. It's basically a website. And once you click on it, click on the link from your MyLabs Plus account, it goes directly into StatCrunch. You don't have to sign in, since you're already signed in with MyLabs Plus. Okay, so the first thing you want to do is sorry, can't type it in yet. You have to choose the option to type the data set, because there's other options to copy the data set from a list somewhere else or to access the data set from the textbook, but those options are not available. Since this is a homework problem, you do have to type it in yourself. So once you do that, you're going to go ahead and type the data in the first column. And after you type the data in the first column, you're going to click on Stat. And once you do Stat, you're going to do Summary. You're going to choose the drop-down Summary Stats. And make sure you do it by column. You're going to click on var1, which is the name of your column, so that it goes into, it transfers into the second box. And then the last thing you're going to do is click compute. And then check your work. Okay, you can also find that from the textbook. So our work should say 4, 14, 18, 32, 63. All right, so I have the output, and the output is right here. So there's my minimum, there's my maximum, there's my middle or my quartile 2, that's the median. There's my quartile 3 and my quartile 1. So according to this output, we did everything correctly. Okay? Now let's see if my graph was close, and it's pretty close. But as you can see, 18 and 32 should have been a little bit more further apart, and the 18 should have been closer to my 14, which is only a difference of 4. So that's the only part that I didn't really do accurately, but it's pretty much what it should look like. Okay, so if you have any questions, please let me know, but this will help you on various problems in the homework. Okay, so yes, you can use your technology to get your answers, but just make sure you know how to take a data set like these 18 and split it in half, find the median, find the minimum, the maximum, and then split the first half in half. Just find the middle, that's the first quartile, and the third quartile will be the median of the second half. So this concludes basically 3.4. A lot of information, and hopefully you can get some work done, and I will see you next week, or see you in the next video. All right, bye-bye.